teach at Mount Pleasant High School. My subjects is primarily physiology. I don't know, I think I've been MESA for 10 years now.
Longer.
Has it? Oh,
Yeah.
All right. My email is up there. It's b2b@esuhsp.org. If you have questions about model science or we need some tips from our students who have done so. The image that you see is of a bisected human brain, which is what the competition is about. I pulled it from some MESA site, so that's a project that one of the MESA students actually did. It's made of a variety of materials. It's also freestanding, which is part of the rules. The model science is for grades 9 and 10, so your freshmen and sophomores, which I always thought was kind of funny because life science is taught at the very, very end of sophomore year, and so you really haven't had this content in their classrooms. It's an individual/team competition, and it's usually one person or pair. I encourage the pairs so that the students can learn how to work together. So here's my first error. The students are going to be creating a bisected human brain and will answer questions from the MESA curriculum. So at the if you guys have looked at the rules for model science, you'll see that there is a list of questions, a full page that they'll have to answer from. And that is my tip. You should probably have them answer those first before you start giving them materials or before you suggest what they might use. So start with the questions first. Is this a topic that they're actually interested in? It's also a good way for them to get their head into the project, because once they start learning about the brain, then it brings them to, oh yeah, well I can use this for this, and this is probably a good material for the cerebellum, etc. First and foremost, the material must not be perishable. I teach high school, must involve a bake. So everything is, can I make candy out of it? Can I make a cake out of it? Can I be a cake pop out of it? That's what my students want to do. But please trust your students that if they have anything that's perishable, it's not going to work. It will be disqualified, and obviously if this is something they did ahead of time, it will be moldy and disgusting by the time messaging runs around. They also cannot buy a model of a bisected brain. And plus, models are quite expensive. I still can't afford to buy one for my classroom. So there you go. But they are out there, and students can purchase them. But obviously, if they purchase something, it will be DQ'd.
Could they use dry macaroni? It won't rot, but can they use that as part of the brain?
And I don't think that's we used macaroni, right? Anyone clarify? I said it's food, you can't use it.
Yeah, I know I saw some eyes last year and they had macaroni on it, so it wasn't clear to me if that was considered perishable by moldiness or perishable by, you know what I mean. If it's like rice or macaroni and it's not going to rot, can they use it? But if it's perishable and moldy, I understand they can't use it. But can they use rice and macaroni for iPhone?
I always told my students, if it's food, you can't use it. That's what I'm doing. Yeah, I mean, I don't want them to get to the point where they get to competition and some judge says, well, it could be perishable, so that's what we do. Right. My rule is, if it's food, you can't use it. So I don't know what the official MESA is for, MESA rule is for the junior high school, but I know from model science, that's what we tell our students. Okay.
No food this year. Might get disqualified.
Okay. Yep. Right. Once again, it has to be a bisected brain, and I repeat this in my presentation because I had a student last year made a beautiful brain, gigantic. It wasn't bisected, so they forget that it has to be a bisected brain, meaning it has to start from the frontal lobe all the way back to the cerebellum. That's a complete bisected brain. try to be as original as possible. When I ask students who's interested in this, I try not to show them a model as much as possible. Of course, they're going to turn to Google. First thing they're going to do is turn to Google and look up a model of a human brain. But, you try to get them away from that, simply by saying, think of materials you can use yourself. If your classroom is like my MESA classroom, it's a zoo. And then we have bins of random stuff. I have my students go through those bins just to pull out materials. And most of those items that I have is from Raft. And I'm pretty sure many of you are familiar with Raft. They have lots of items that the students can use for their project. The only thing that they don't have, which I highly encourage they get, or at least maybe your club can get, is the modeling clay. Okay, modeling clay is fantastic for almost anything. And there's a variety of them. I highly encourage the Model Magic Clay. It's called Crayola Model Magic Clay is what I suggest in terms of getting clay. Because if you get just air dry clay will dry and become brittle and it'll fall apart. So that's a huge problem. Because the kids trying to hot glue it that morning, it's a fiasco. So Crayola Model Magic Clay and they come in all kinds of different colors. So that's nice. The judges always ask what materials you use. So if the students do paint on their clay, they should be ready with the materials list, and that's actually part of the competition, that the students have a materials list, and I'll show you that in a little bit. Again, with the stress of MESA Day, students often forget to put their name on it, and you don't know if the model belongs to this display or, whatever, things happen. Please encourage them to put their name first on their backboard, and then, of course, on their actual model so that it's visible and we're not having to lift the model looking for someone's name. So if they just put it right on the top, right on the stand, it's easy to see, they can match it to the display board right away. It does have to have your school name, the student's school name, and the center. This is always a question for my students, especially the freshmen. What center do I belong in? They don't know. So it's San Jose State. This is the display size requirements. What I'm showing in the picture is your basic trifold science poster, just like the one in the back. So that is the display board size that the students will use. I think it's legitimate to use the smaller ones, but most students like just those for free. We give it to them, so they just use that board. Other students may opt for the foam core board, which is nicer, it's stiffer, but it's also $14 at least for one foam core board. Another thing is that Raft has them. I just went there a week ago. The foam core boards were selling for $250. So that's a huge savings for us. The display, including all of the components, which is the actual model, plus the backboard, should not be larger than 3 feet high, 3 feet wide, by 2 feet deep. The model can be attached to the back, but then you sometimes have issues with the display falling backwards. It's just easier if the model stands by itself and then the display board stands by itself. So again, this is a MESA Day. How many years ago was it hard? Does anybody know? Christina, you know, Rance?
Say that one more time.
How many years ago was it hard?
Art?
Yeah.
2 years ago?
Yeah. So this is our MESA picture from 2 years ago that our students did. And the rules really hasn't changed very much, just the topic has changed. Again, I'm showing you a bisected human brain with the label. This is an actual, the store-bought model. The model itself is no larger than 2 feet high by 2 feet wide by 2 feet deep. And that's really large. I had a student last year who decided to make the possible largest brain, and it was massive. It was a giant pinata. But that is, it's within size. You don't want it too small. Okay, no tiny little brain models because it's difficult to see. I think you want to probably tell your students to try to stay within the shoebox size because that's easy to transport. It's also visible enough, but if you get to the size of a 2 feet high by 2 feet wide and 2 feet deep, it was big. It required multiple people to hold the brain that we had last year. Models must be clearly labeled. This is a model that my students just did for my class, for my physiology class, showing the outer structures of the brain. But that is made out of, I wish it were clear, but it's made out of the Model Magic clay and a styrofoam ball. And obviously the labels are made of toothpicks that the students had in their house. And they just painted the structures around it. So they do have to make sure that their structure is clearly labeled. Even if they have nice handwriting, I encourage them to type it. Encourage them to type all of their labels. The required structures. So there is a spreadsheet in your MESA packets that's available online, of course. This is the required structures. There's 14 of them, starting from the cranium, the cerebral cortex, the frontal lobes, parietal lobes, occipital lobes, temporal lobe. And this doesn't make sense to the students at all unless they did the questions in the very beginning. And I'm not the type of teacher that gives my students answers. I tell them, this is where you can find it. When you're ready, show me what you've done, and then I can help you out from that point. But they're going to start to sit there and they're going to speak to where's the parietal lobe, where's the cerebellum. I'm not going to tell them those answers because I want them to do the searching before they come to me. And then if they figure it out, then I say, okay, well, you're accurate or you're inaccurate. But that's the idea with this project. It's not just to make a model, but actually do the little research yourself. So they get points for it being there and also for the label. So again, in the rush of things, the students forget to do the label, they make it, but they do lose half the points simply by not putting that name on there. All right, so the other structures are the hypothalamus, the pituitary gland, the midbrain, the cerebellum, the pons, and the medulla oblongata. Most of these structures are in the bisected portion, so they can't figure out where these things are unless they actually cut the brain in half and label it. There are bonus points to this project. If they add 6 additional structures, and there's plenty of them out there, they can actually get additional points, up to 6 points. And again, it should be labeled and present on their spreadsheet. So this is an example of a materials table. The materials table should be on the display board. It should list out every single structure they have and have labeled, and what material they use. So this is a good introduction to how to use a spreadsheet, or just that tables feature on a Microsoft Word for your students. Or like, of course, they can also hand draw it, but it looks professional if you teach them how to do the spreadsheet, which I had to do for our students as well. One year, we had a group of students who tried to be overtly creative in their materials, and they used everything but the kitchen sink, and everything possible. So every single structure was a different material, and that didn't go over so well. It was interesting, but even though they use different materials, they still have to look like the actual thing. So you're going to have to tell the students, you have to draw a fine line between creativity and messiness and kind of sloppiness in terms of the material. Because it still has to look like the actual brain and not be some mishmash of material you found in your kitchen. Math is great until it becomes chaos. So, the poster must have a bisected hand drawing. I pulled this one today from my classroom. It's a hand-drawn brain. Obviously, it's not bisected. the view from underneath the brain. If your students are good with computers, they can use any of the drawing programs. I'm not familiar with them, so I just tell my students hand drawn is good. But if they are familiar with paints, and many students are, they can use paint to do their hand drawings. But they can't just cut and paste and put it on their poster board and call it a day. It has to be hand drawn or redrawn in some type of computer program. And it also has to be labeled, of course. So here's another example of a hand-drawn brain. Okay? It only shows one side, and of course, it's a different way to do it. Are there any questions at this point?
I just wanted to let everyone know too, for those of you who are doing the I for junior high, the same rules apply. So same rules apply as to the brain. There's always questions they have to answer, and it has to be a dissected version, and everything has to be clearly labeled and no perishables. So they're actually the same rules. There's just more questions and more points in high school than there is in the junior high level.
But do you get extra points for adding on more iPhones?
No, you
No.
just gotta look at the rules. There's only a certain amount
There's
of extra
14.
points they can get.
There's
Yeah.
14 parts they want in the label, but
Ours is 14 required and 6 additional.
Yeah.
Oh, okay.
and do the stands, I noticed some kids spend time and they make the stand, and some kids just use a bow.
As long as the model can sit there by itself and not be like rolling
Walking.
around.
But they don't
It's
get any extra
freestanding.
points for making their own stand.
They don't. They don't. But their stand and their model all have to fit within that dimension in the very beginning. So again, if they make these giant,
Because I saw someone just use a bow, and then I saw someone
yeah,
who constructed a stand and blended it in with the eye and made it look like part of the eye. I
Yeah.
go, oh, that's extra work.
it's as long as it stands, sits there by itself. So it's not going to fall off the table.
So
They
there's-
can lean it against the display board, but I tell my students, okay, well, if you lean it against your display board and your model's heavy, then it's gonna look like a mess with your thing all falling all over the place.
So there's actually a dimension limit then for the eye?
I'm pretty sure it is, but I'm not sure. I haven't looked at the.
I haven't read the details, I just took that.
Yeah, it's pretty much the same dimensions, and your poster board has to be similar. Yeah.
So you said the stand is part of the 2 feet by 2 feet?
Everything has to fit in that space, yeah. Okay. So the students should be ready for the Q&A. And the students are famous for procrastination. I actually called my students, they're not pleasant, we're master procrastinators, MP, master procrastinators, because our students were drilling each other on the bus, on the way to mess today. It's just the way students are, you know. But a good Q&A session, they really have those questions down. A good way to do it is also, if they're doing it in pairs, is to split it in half. You're the expert of 1 through 10, I'm the expert from 11 to 20, and then we kind of play off of each other if we need to add something that I didn't previously say. There should be, some students put the questions on the backboard, okay? But I tell my students, well, does that show your expertise in the project, or just that you cheated cheated in a way because you put your questions on the backboard? I don't like it. I tell my students to try to avoid it because they're the ones that should be an expert at their topic, not their display board. And they should never face the display board when they're presenting during the Q&A session.
What was that? They should never face their.
Yeah, when I teach my own physiology students, I tell them, if you're gonna present and you're doing the Q&A, you're not talking to your board that's behind you. You're not talking, again, to your model, you're talking to the people that are in front of you. So don't be looking at your display board for answers. Your display board is to show what you produce, not necessarily what you know. What you know should be in your brain. Maybe have a note card in front of you, but not be, oh, your answer to that, the answer to that question is valid. It shows lack of preparation. tiebreaker questions. So sometimes the students happen to know every single question on that list. So there are questions that are not published that the judges will ask the students. So these are the examples of questions that are on the list. So which part of the brain is important for reasoning? Where is it located? And describe the 3 functions of the nervous system. So looking over it, it's basically a general overview of the brain. As I mentioned before, there are 6 additional structures that they can get for their project if they had it, and then they're the judging. So the judging is accuracy. Excuse me. As I said, don't be overtly creative. It still has to look like a real brain. To stress to your students that it has to be the general size of the structure. So for example, the pituitary gland, which is the size of a pea, and the human brain can't be the same size as the cerebellum, which is about the size of a tennis ball. So they have to have relative sizes to be accurate. They should be original in their project. It can't be, I just rehashed my older sister's project. Okay? I have multiple students who come through and they try to pull that. You know, they try to pull somebody else's project in the past because their older sibling had it or they've seen it before. And no, it's not yours. You have to be original in your project. They should use a variety of colors, textures, length, and dimensions as well. And of course, as I said, there's going to be the Q&A session. We'll have to be able to answer questions for the MESA curriculum from the prescribed list. They do get partial credit. I think that's pretty lenient of the judges to give them partial credit, but they do get partial credit. They can answer part of it. There's a tiebreaker question. This is what I mentioned. It's not published. So if there is a situation where the students are in a deadlock, they will have to be held accountable for this extra knowledge. And last but not least, there's a checklist at the very end of the project, okay? At the very end of the packet. I suggest you show them this first, because if you show them what they're headed towards, then they know, oh, I gotta make sure I do this, I gotta make sure I do that. So they're not missing anything in the project, and they don't get disqualified. Obviously, my student who didn't buy something great didn't do the checklist. Yes?
I noticed that it keeps saying bisected human head. Does that mean you have to show the external anatomy as well as head versus brain?
So you don't have to include the head. It has to be the brain.
Okay,
But some students prefer the
head.
yeah. But some students prefer to have the head outline. Right. It's just the brain. The brain is the one that they actually.
If I were the student and I was a judge, I would say not to include the head features or wasting your time. You're wasting your time. I would say not to include the head.
I was just noticing it keeps repeating human head instead of human brain.
Yeah, it's really needs the brain.
Okay.
Yeah, I feel like if they're doing that, then it's going to be a waste of their resources.
Any other questions? Yes.
I know bisected means to cut in half, but also bisected can mean in 2 pieces. Can they cut it like 3/4?
The problem with doing it in any other bisected portion, whether it be like a coronal cut, is that we don't show the structures that's needed for the project.
So all the projects.
It should be right down the center so that the 2 hemispheres are completely split in half.
Does the eye need to be bisected also, or can
Yes.
it be cut?
We were just checking the rules, the eye should needs to be bisected.
But
And
I
that's
didn't know
4
what
bonus
was
points.
because the eye isn't so
I would suggest for the eye, just saying that right down the center.
right now.
Right. So you get all of the anterior structures and all of the posterior structures as well. It's too difficult to show I think it's difficult to show the eye if you bisect it this way.
I got a student who took a quarter out, so I think the quarter
Yeah.
out. So they can look down on house and look sideways on house, but it's not
not bisected. Because bisected
This should be right on.
two equal halves.
Yeah.